This is a reading from Alfred North Whitehead's book, Modes of Thought, published in 1938, Part 3, Nature and Life, Chapter 7, Nature Lifeless. Philosophy is the product of wonder. The effort after the general characterization of the world around us is the romance of human thought. The correct statement seems so easy, so obvious, and yet it is always eluding us. We inherit the traditional doctrine. We can detect the oversights, the superstitions, the rash generalizations of the past ages. We know so well what we mean, and yet we remain so curiously uncertain about the formulation of any detail of our knowledge. This word detail lies at the heart of the whole difficulty. You cannot talk vaguely about nature in general. We must fix upon details within nature and discuss their essences and their types of interconnection. The world around us is complex, composed of details. We have to settle upon the primary types of detail in terms of which we endeavor to express our understanding of nature. We have to analyze and to abstract, and to understand the natural status of our abstractions. At first sight, there are shortcut classes within which we can sort the various types of things and characters of things which we find in nature. Every age manages to find modes of classification which seem fundamental starting points for the researches of the special sciences. Each succeeding age discovers that the primary classifications of its predecessors will not work. In this way, a doubt is thrown upon all formulations of laws of nature, which assume these classifications as firm starting points. A problem arises. Philosophy is the search for the solution. Our first step must be to define the term nature as here used. Nature in these chapters means the world as interpreted by reliance on clear and distinct sensory experiences, visual, auditory, and tactile. Obviously, such an interpretation is of the highest importance for human understanding. These final chapters are concerned with the question, how far does it take us? For example, we can conceive nature as composed of permanent things, namely, bits of matter moving about in space which otherwise is empty. This way of thinking about nature has an obvious consonance with common sense observation. There are chairs, tables, bits of rock, oceans, animal bodies, vegetable bodies, planets, and suns. The enduring self-identity of a house, of a farm, of an animal body is a presupposition of social intercourse. It is assumed in legal theory. It lies at the base of all literature. A bit of matter is thus conceived as a passive fact, an individual reality which is the same at any instant, or throughout a second, an hour, or a year. Such a material, individual reality supports its various qualifications such as shape. Such a material individual reality supports its various qualifications such as shape, locomotion, color or smell, etc. The occurrences of nature consist in the changes in these qualifications, and more particularly in the changes of motion. The connection between such bits of matter consists purely of spatial relations. Thus, the importance of motion arises from its change of the sole mode of interconnection of material things. Mankind then proceeds to discuss these spatial relations and discovers geometry. The geometrical character of space is conceived as the one way in which nature imposes determinate relations upon all bits of matter which are the sole occupants of space. In itself, space is conceived as unchanging from eternity to eternity, and as homogeneous from infinity to infinity. Thus, we compose a straightforward characterization of nature, which is consonant to common sense, and can be verified at each moment of our existence. We sit for hours in the same chair, in the same house, with the same animal body. The dimensions of the room are defined by its spatial relations. There are colors, sounds, scents, partly abiding and partly changing. Also, the major facts of change are defined by locomotion of the animal bodies and of the inorganic furniture. Within this general concept of nature, there have somehow to be interwoven the further concepts of life and mind. I have been endeavoring to sketch the general common sense notion of the universe, which, about the beginning of the 16th century, say in the year 1500 AD, was in process of formation among the more progressive thinkers of the European population. It was partly an inheritance from Greek thought and from medieval thought. Partly it was based on the deliverance of direct observation, at any moment verified in the world around us. It was the presupposed support supplying the terms in which the answers to all further questions were found. Among these further questions, the most fundamental and the most obvious are those concerning the laws of locomotion, the meaning of life, the meaning of mentality, and the interrelations of matter, life, and mentality. When we examine the procedures of the great men in the 16th and 17th centuries, we find them presupposing this general common sense notion of the universe and endeavoring to answer all questions in the terms it supplies. I suggest that there can be no doubt but that this general notion expresses large, all-pervading truths about the world around us. The only question is as to how fundamental these truths may be. In other words, we have to ask what large features of the universe cannot be expressed in these terms. We have also to ask whether we cannot find some other set of notions which will explain the importance of this common sense notion and will also explain its relation to those other features ignored by the common sense notion. When we survey the subsequent course of scientific thought throughout the 17th century up to the present day, two curious facts emerge. In the first place, the development of natural science has gradually discarded every single feature of the original common sense notion. Nothing whatever remains of it, considered as expressing the primary features in terms of which the universe is to be interpreted. The obvious common sense notion has been entirely destroyed, so far as concerns its function as the basis for all interpretation. One by one, every item has been dethroned. There is a second characteristic of subsequent thought, which is equally prominent. This common sense notion still reigns supreme in the workaday life of mankind. It dominates the marketplace, the playgrounds, the law courts, and in fact the whole sociological intercourse of mankind. It is supreme in literature and is assumed in all humanistic sciences. Thus, the science of nature stands opposed to the presuppositions of humanism. Where some conciliation is attempted, it often assumes some sort of mysticism, but in general there is no conciliation. Indeed, even when we confine attention to natural science, no special science ever is grounded upon the conciliation of presuppositions belonging to all the various sciences of nature. Each science confines itself to a fragment of the evidence and weaves its theories in terms of notions suggested by that fragment. Such a procedure is necessary by reason of the limitations of human ability, but its dangers should always be kept in mind. For example, the increasing departmentalization of universities during the last 100 years, however necessary for administrative purposes, tends to trivialize the mentality of the teaching profession. The result of this effective survival of two ways of thought is a patchwork procedure. Presuppositions from the two points of view are interwoven sporadically. Every special science has to assume results from other sciences. For example, biology presupposes physics. it will usually be the case that these loans from one specialism to another really belong to the state of science 30 or 40 years earlier. The presuppositions of the physics of my boyhood are today powerful influences in the mentality of physiologists. Indeed, we do not need even to bring in the physiologists. The presuppositions of yesterday's physics remain in the minds of physicists, although their explicit doctrines, taken in detail, deny them. In order to understand this sporadic interweaving of old and new in modern thought, I will recur to the main principles of the old common sense doctrine, which even today is the common doctrine of ordinary life because, in some sense, it is true. There are bits of matter enduring self-identically in space which is otherwise empty. Each bit of matter occupies a definite limited region. Each such particle of matter has its own private qualifications, such as its shape, its motion, its mass, its color, its scent. Some of these qualifications change, others are persistent. The essential relationship between bits of matter is purely spatial. Space itself is eternally unchanging, always including in itself this capacity for the relationship of bits of matter. Geometry is the science which investigates this spatial capacity for imposing relationship upon matter. Locomotion of matter involves change in spatial relationship. It involves nothing more than that. Matter involves nothing more than spatiality and the passive support of qualifications. It can be qualified, and it must be qualified. But qualification is a bare fact, which is just itself. This is the grand doctrine of nature as a self-sufficient, meaningless complex of facts. It is the doctrine of the autonomy of physical science. It is the doctrine which, in these lectures, I am denying. The state of modern thought is that every single item in this general doctrine is denied, but that the general conclusions from the doctrine as a whole are tenaciously retained. The result is a complete muddle in scientific thought, in philosophic cosmology, and in epistemology. But any doctrine which does not implicitly presuppose this point of view is assailed as unintelligible. The first item to be abandoned was the set of qualifications which we distinguish in sense perception, namely color, sound, scent, and analogous qualifications. The transmission theories for light and sound introduced the doctrine of secondary qualities. The color and the sound were no longer in nature. They are the mental reactions of the percipient to internal bodily locomotions. Thus, nature is left with bits of matter, qualified by mass, spatial relations, and the change of such relations. The loss of the secondary qualities was a severe restriction to nature, for its value to the percipient was reduced to its function as a mere agent of excitement. Also, the derived mental excitement was not primarily concerned with factors in nature. The colors and the sounds were secondary factors supplied by the mental reaction. But the curious fact remained that these secondary factors are perceived as related by the spatiality which is the grand substratum of nature. Hume was, I think, the first philosopher who explicitly pointed out this curious hybrid character of our perceptions, according to the current doctrine of the perception of secondary qualities. Though, of course, this hybrid characteristic was tacitly presupposed by Locke when he conceived color as a secondary quality of the things in nature. I believe that any cosmological doctrine which is faithful to the facts has to admit this artificial character of sense perception. Namely, when we perceive the red rose, we are associating our enjoyment of red derived from one source with our enjoyment of a spatial region derived from another source. The conclusion that I draw is that sense perception, for all its practical importance, is very superficial in its disclosure of the nature of things. This conclusion is supported by the character of delusiveness that is of illusion which persistently clings to sense perception. For example, our perception of stars which years ago may have vanished, our perceptions of images in mirrors or by refraction, our double vision, our visions under the influence of drugs. My quarrel with modern epistemology concerns its exclusive stress upon sense perception for the provision of data respecting nature. Sense perception does not provide the data in terms of which we interpret it. This conclusion that pure sense perception does not provide the data for its own interpretation was the great discovery embodied in Hume's philosophy. This discovery is the reason why Hume's treatise will remain as the irrefutable basis for all subsequent philosophic thought. Another item in the common sense doctrine concerns empty space and locomotion. In the first place, the transmission of light and sound shows that space apparently empty is the theater of activities which we do not directly perceive. This conclusion was explained by the supposition of types of subtle matter, namely the ether, which we cannot directly perceive. In the second place, this conclusion and the obvious behavior of gross ordinary matter shows us that the motions of matter are in some way conditioned by the spatial relations of material bodies to each other. It was here that Newton supplied the great synthesis upon which science was based for more than 2 centuries. Newton's laws of motion provided a skeleton framework within which more particular laws for the interconnection of bodily motions could be inserted. He also supplied one example of such a particular law in his great law of gravitation, which depended upon mutual distances. Newton's methodology for physics was an overwhelming success, but the forces which he introduced left nature still without meaning or value. In the essence of a material body, in its mass, motion, and shape, there was no reason for the law of gravitation. Even if the particular forces could be conceived as the accidents of a cosmic epoch, there was no reason in the Newtonian concepts of mass and motion why material bodies should be connected by any stress between them. Yet the notion of stresses as essential connections between bodies was a fundamental factor in the Newtonian concept of nature. What Newton left for empirical investigation was the determination of the particular stresses now existing. In this determination, he made a magnificent beginning by isolating the stresses indicated by his law of gravitation, but he left no hint why in the nature of things there should be any stresses at all. The arbitrary motions of the bodies were thus explained by the arbitrary stresses between material bodies conjoined with their spatiality, their mass, and their initial states of motion. By introducing stresses, in particular the law of gravitation, instead of the welter of detailed transformations of motion, he greatly increased the systematic aspect of nature. But he left all the factors of the system, more particularly mass and stress, in the position of detached facts devoid of any reason for their calm presence. He thus illustrated a great philosophic truth, that a dead nature can give no reasons. All ultimate reasons are in terms of aim at value. A dead nature aims at nothing. It is the essence of life that it exists for its own sake, as the intrinsic reaping of value. Thus, for Newtonians, nature yielded no reasons. It could yield no reasons. Combining Newton and Hume, we obtain a barren concept, namely, a field of perception devoid of any data for its own interpretation, and a system of interpretation devoid of any reason for the concurrence of its factors. It is this situation that modern philosophy from Kant onwards has, in its various ways, sought to render intelligible. My own belief is that this situation is a reductio ad absurdum and should not be accepted as the basis for philosophic speculation. Kant was the first philosopher who in this way combined Newton and Hume. He accepted them both, and his three critiques were his endeavor to render intelligible this Hume-Newton situation. But the Hume-Newton situation is the primary presupposition for all modern philosophic thought. Any endeavor to go behind it is, in philosophic discussion, almost angrily rejected as unintelligible. My aim in these lectures is briefly to point out how both Newton's contribution and Hume's contribution are, each in their own way, gravely defective. They are right as far as they go, but they omit those aspects of the universe as experienced and of our modes of experiencing which jointly lead to the more penetrating ways of understanding. In the recent situations at Washington, D.C., the Hume-Newton modes of thought can only discern a complex transition of sensa and an entangled locomotion of molecules, while the deepest intuition of the whole world discerns the President of the United States inaugurating a new chapter in the history of mankind. In such ways, the Hume-Newton interpretation omits our intuitive modes of understanding. I now pass on to the influence of modern science in discrediting the remaining items of the primary common sense notion with which science in the 16th century started its career. But in the present-day reconstruction of physics, fragments of the Newtonian concepts are stubbornly retained. The result is to reduce modern physics to a sort of mystic chant over an unintelligible universe. This chant has the exact merits of the old magic ceremonies which flourished in ancient Mesopotamia and later in Europe. One of the earliest fragments of writing which has survived is a report from a Babylonian astrologer to the king, stating the favorable days to turn cattle into the fields, as deduced by his observation of the stars. This mystic relation of observation, theory, and practice is exactly the present position of science in modern life, according to the prevalent scientific philosophy. The notion of empty space, the mere vehicle of spatial interconnections, has been eliminated from recent science. The whole spatial universe is a field of force, or, in other words, a field of incessant activity. The mathematical formula of physics express the mathematical relations realized in this activity. The unexpected result has been the elimination of bits of matter as the self-identical supports for physical properties. At first, throughout the 19th century, the notion of matter was extended. The empty space was conceived as filled with ether. This ether was nothing else than the ordinary matter of the original common sense notion. It had the properties of a jelly, with its continuity, its cohesion, its flexibility, and its inertia. The ordinary matter of common sense then merely represented certain exceptional entanglements in the ether, that is to say, knots in the ether. These entanglements, which are relatively infrequent throughout space, impose stresses and strains throughout the whole of the jelly-like ether. Also, the agitations of ordinary matter are transmitted through the ether as agitations of the stresses and strains. In this way, an immense unification was effected of the various doctrines of light, heat, electricity, and energy, which now coalesced into the one science of the ether. The theory was gradually elaborated throughout the 19th century by a brilliant group of physicists and mathematicians, French, German, Dutch, Scandinavian, British, Italian, American. The details of their work and the relative contributions of various individuals are not the point here. The final result is that the activities of the ether are very different from any of the modes of activity which the common sense analysis ascribes to ordinary matter. If the doctrine of ether be correct, then our ordinary notions of matter are derived from observations of certain average results which cloak the real nature of the activities of ether. The more recent revolution, which has culminated in the physics of the present day, has only carried one step further this trend of 19th century science. Its moral is the extreme superficiality of the broad generalizations which mankind acquires on the basis of sense perception. The continuous effort to understand the world has carried us far away from all those obvious ideas. Matter has been identified with energy, and energy is sheer activity. The passive substratum composed of self-identical enduring bits of matter has been abandoned, so far as concerns any fundamental description. Obviously, this notion expresses an important derivative fact, but it has ceased to be the presupposed basis of theory. The modern point of view is expressed in terms of energy, activity, and the vibratory differentiations of spacetime. Any local agitation shakes the whole universe. The distant effects are minute, but they are there. The concept of matter presupposed simple location. Each bit of matter was self-contained, localized in a region with a passive static network of spatial relations, entwined in a uniform relational system from infinity to infinity and from eternity to eternity. But in the modern concept, the group of agitations which we term matter is fused into its environment. There is no possibility of a detached, self-contained local existence. The environment enters into the nature of each thing. Some elements in the nature of a complete set of agitations may remain stable, as those agitations are propelled through a changing environment, but such stability is only the case in a general average way. The average fact is the reason why we find the same chair, the same rock, and the same planet enduring for days or for centuries or for millions of years. In this average fact, then, time factor takes the aspect of endurance, and change is a detail. The fundamental fact, according to the physics of the present day, is that the environment with its peculiarities seeps into the group agitation which we term matter, and the group agitations extend their character to the environment. In truth, the notion of the self-contained particle of matter, self-sufficient within its local habitation, is an abstraction. Now, an abstraction is nothing else than the omission of part of the truth. The abstraction is well-founded when the conclusions drawn from it are not vitiated by the omitted truth. This general deduction from the modern doctrine of physics vitiates many conclusions drawn from the applications of physics to other sciences, such as physiology, or even such as physics itself. For example, when geneticists conceive genes as the determinants of heredity, the analogy of the old concept of matter sometimes leads them to ignore the influence of the particular animal body in which they are functioning. They presuppose that a pellet of matter remains in all respects self-identical, whatever be its changes of environment. So far as modern physics is concerned, any characteristics may or may not affect changes in the genes, changes which are as important in certain respects, though not in others. Thus, no a priori argument as to the inheritance of characters can be drawn from the mere doctrine of genes. In fact, recently physiologists have found that genes are modified in some respects by their environment. The presuppositions of the old common-sense view survive, even when the view itself has been abandoned as a fundamental description. This survival of fragments of older doctrines is also exemplified in the modern use of the term spacetime. The notion of space, with its geometry, is strictly coordinated to the notion of material bodies with simple location in space. A bit of matter is then conceived as self-sufficient, with the simple location of the region which it occupies. It is just there, in that region where it is, and it can be described without reference to the goings-on in any other region of space. The empty space is the substratum for the passive geometrical relationships between material bodies. These relationships are bare, static facts and carry no consequences which are essentially necessary. For example, Newton's law of gravitation expresses the changes of locomotion which are associated with the spatial relations of material bodies with each other. But this law of gravitation does not result from the Newtonian notion of mass combined with the notion of the occupancy of space together with the Euclidean geometry. None of these notions, either singly or in combination, give the slightest warrant for the law of gravitation. Neither Archimedes nor Galileo, by puzzling over these notions, could have derived any suggestion for the gravitational law. According to the doctrine, space was the substratum for the great all-pervading passive relationship of the natural world. It conditioned all the active relationships, but it did not necessitate them. The new view is entirely different. The fundamental concepts are activity and process. Nature is divisible and thus extensive, but any division, including some activities and excluding others, also severs the patterns of process which extend beyond all boundaries. The mathematical formulae indicate a logical completeness about such patterns, a completeness which boundaries destroy. For example, half a wave tells only half the story. The notion of self-sufficient isolation is not exemplified in modern physics. There are no essentially self-contained activities within limited regions. These passive geometrical relationships between substrata passively occupying regions have passed out of the picture. Nature is a theater for the interrelations of activities. All things change, the activities and their interrelations. To this new concept, the notion of space with its passive, systematic, geometric relationship is entirely inappropriate. The fashionable notion that the new physics has reduced all physical laws to the statement of geometrical relations is quite ridiculous. It has done the opposite. In the place of the Aristotelian notion of the procession of forms, it has substituted the notion of the forms of process. It has thus swept away space and matter, and has substituted the study of the internal relations within a complex state of activity. This complex state is, in one sense, a unity. There is the whole universe of physical action extending to the remotest star cluster. In another sense, it is divisible into parts. We can trace interrelations within a selected group of activities and ignore all other activities. By such an abstraction, we shall fail to explain those internal activities which are affected by changes in the external system which has been ignored. Also, in any fundamental sense, we shall fail to understand the retained activities, for these activities will depend upon a comparatively unchanging systematic environment. In all discussions of nature, we must remember the differences of scale, and in particular the differences of time span. We are apt to take modes of observable functioning of the human body as setting an absolute scale. It is extremely rash to extend conclusions derived from observations far beyond the scale of magnitude to which observation was confined. For example, to exhibit apparent absence of change within a second of time tells nothing as to the change within 1,000 years. Also, no apparent change within 1,000 years tells anything as to 1,000,000 years. And no apparent change within 1,000,000 years tells anything about 1,000,000,000,000 years. We can extend this progression indefinitely. There is no absolute standard of magnitude. Any term in this progression is large compared to its predecessor and small compared to its successor. Again, all special sciences presuppose certain fundamental types of things. Here I am using the word thing in its most general sense, which can include activities, colors, and other sensa, and values. In this sense, thing is whatever we can talk about. A science is concerned with a limited set of various types of things. There is thus, in the first place, this variety of types. In the second place, there is the determination as to what types are exhibited in any indicated situation. For example, there is the singular proposition, "This is green," and the more general proposition, "All those things are green." This type of inquiry is what the traditional Aristotelian logic takes care of. Undoubtedly, such inquiries are essential in the initial stage of any science. But every science strives to get beyond it. Unfortunately, owing to the way in which, for over 2,000 years, philosophic thought has been dominated by its background of Aristotelian logic, all attempts to combine the set of special sciences into a philosophic cosmology, giving some understanding of the universe, all these attempts are vitiated by an unconscious relapse into these Aristotelian forms as the sole mode of expression. The disease of philosophy is its itch to express itself in the forms "some S is P" or "all S is P." Returning to the special sciences, the third step is the endeavor to obtain quantitative decisions. In this stage, the typical questions are, how much P is involved in S, and how many S's are P? In other words, number, quantity, and measurement have been introduced. A simple-minded handling of these quantitative notions can be just as misleading as undue trust in the Aristotelian forms for propositions. The fourth stage in the development of the science is the introduction of the notion of pattern. Apart from attention to this concept of pattern, our understanding of nature is crude in the extreme. For example, given an aggregate of carbon atoms and oxygen atoms, and given that the number of oxygen atoms and the number of carbon atoms are known, the properties of the mixture are unknown until the question of pattern is settled. How much free oxygen is there? How much free carbon? How much carbon monoxide? How much carbon dioxide? The answers to some of these questions, with the total quantities of oxygen and of carbon presupposed, will determine the answer to the rest. But even allowing for this mutual determination, there will be an enormous number of alternative patterns for a mixture of any reasonable amount of carbon and oxygen. And even when the purely chemical pattern is settled, and when the region containing the mixture is given, there are an indefinite number of regional patterns for the distribution of the chemical substances within the containing region. Thus, beyond all questions of quantity, there lie questions of pattern, which are essential for the understanding of nature. Apart from a presupposed pattern, quantity determines nothing. Indeed, quantity itself is nothing other than analogy of functions within analogous patterns. Also, this example, involving mere chemical mixture and chemical combination, and the seclusion of different substances in different subregions of the container, shows us that that notion of pattern involves the concept of different modes of togetherness. This is obviously a fundamental concept which we ought to have thought of as soon as we started with the notion of various types of fundamental things. The danger of all these fundamental notions is that we are apt to assume them unconsciously. When we ask ourselves any question, we will usually find that we are assuming certain types of entities involved, that we are assuming certain modes of togetherness of these entities, and that we are even assuming certain widely spread generalities of pattern. Our attention is concerned with details of pattern and measurement and proportionate magnitude. Thus, the laws of nature are merely all-pervading patterns of behavior, of which the shift and discontinuance lie beyond our ken. Again, the topic of every science is an abstraction from the full concrete happenings of natures. But every abstraction neglects the influx of the factors omitted into the factors retained. Thus, a single pattern discerned by vision, limited to the abstractions within a special science, differentiates itself into a subordinate factor in an indefinite number of wider patterns when we consider its possibilities of relatedness to the omitted universe. Even within the circle of the special science, we may find diversities of functioning not to be explained in terms of that science. But these diversities can be explained when we consider the variety of wider relationships of the pattern in question. Today, the attitude among many leaders in natural science is a vehement denial of the considerations which have been put forward. Their attitude seems to me to be a touching example of baseless faith. This judgment is strengthened when we reflect that their position of the autonomy of the natural sciences has its origin in a concept of the world of nature now discarded. Finally, we are left with a fundamental question as yet undiscussed. What are those primary types of things in terms of which the process of the universe is to be understood? Suppose we agree that nature discloses to the scientific scrutiny merely activities and process. What does this mean? These activities fade into each other. They arise and then pass away. What is being enacted? What is effected? It cannot be that these are merely the formula of the multiplication table, in the words of a great philosopher, merely a bloodless dance of categories. Nature is full-blooded. Real facts are happening. Physical nature, as studied in science, is to be looked upon as a complex of the more stable interrelations between the real facts of the real universe. This lecture has been confined to nature under an abstraction, in which all reference to life was suppressed. The effect of this abstraction has been that dynamics, physics, and chemistry were the sciences which guided our gradual transition from the full common-sense notions of the 16th century to the concept of nature suggested by the speculative physics of the present day. This change of view, occupying 4 centuries, may be characterized as the transition from space and matter, as the fundamental notions, to process, conceived as a complex of activity with internal relations between its various factors. The older point of view enables us to abstract from change and to conceive of the full reality of nature at an instant, an abstraction from any temporal duration, and characterized as to its interrelations solely by the instantaneous distribution of matter in space. According to the Newtonian view, what had thus been omitted was the change of distribution at neighboring instants. But such change was, on this view, plainly irrelevant to the essential reality of the material universe at the instant considered. Locomotion and change of relative distribution was accidental and not essential. Equally accidental was endurance. Nature at an instant is, in this view, equally real whether or not there be no nature at any other instant, or indeed whether or not there be any other instant. Descartes, who with Galileo and Newton cooperated in the construction of the final Newtonian view, accepted this conclusion, for he explained endurance as perpetual recreation at each instant. Thus the matter of fact was, for him, to be seen in the instant and not in the endurance. For him, endurance was a mere succession of instantaneous facts. There were other sides to Descartes' cosmology, which might have led him to a greater emphasis on motion, for example, his doctrines of extension and vortices. But in fact, by anticipation, he drew the conclusion which fitted the Newtonian concepts. There is a fatal contradiction inherent in the Newtonian cosmology. Only one mode of the occupancy of space is allowed for, namely, this bit of matter occupying this region at this durationless instant. This occupation of space is the final real fact, without reference to any other instant, or to any other piece of matter, or to any other region of space. Now, assuming this Newtonian doctrine, we ask, what becomes of velocity at an instant? Again, we ask, what becomes of momentum at an instant? These notions are essential for Newtonian physics, and yet they are without any meaning for it. Velocity and momentum require the concept that the state of things at other times and other places enter into the essential character of the material occupancy of space at any selected instant. But the Newtonian concept allows for not such modification of the relation of occupancy. Thus, the cosmological scheme is inherently inconsistent. The mathematical subtleties of the differential calculus afford no help for the removal of this difficulty. We can indeed phrase the point at issue in mathematical terms. The Newtonian notion of occupancy corresponds to the value of a function at a selected point. But the Newtonian physics requires solely the limit of the function at that point. And the Newtonian cosmology gives no hint why the bare fact, which is the value, should be replaced by the reference to other times and places, which is the limit. For the modern view, process, activity, and change are the matter of fact. At an instant there is nothing. Each instant is only a way of grouping matters of fact. Thus, since there are no instants conceived as simple primary entities, there is no nature at an instant. Thus, all the interrelations of matters of fact must involve transition in their essence. All realization involves implication in the creative advance. The discussion in this lecture is only the prolegomenon for the attempt to answer the fundamental question: how do we add content to the notion of bare activity? Activity for what? Producing what? Activity involving what? The next lecture will introduce the concept of life, and will thus enable us to conceive of nature more concretely, without abstraction.